I don't work for Microsoft anymore. I used to work 2 months ago. Now I joined Curai, a startup. So this talk is about a lot of things that I used to do at Microsoft, but at the same time, we'll be talking about what we're working on at this new cool place. All right, so the outline is to give an overview of why knowledge graphs are important nowadays. And then I'm going to go through 3 examples of knowledge graphs that I work on and I'm working on. The first one is one based on social data, in particular Twitter. The second is on e-commerce. And the third one is on healthcare. And then we'll wrap up with conclusions. So knowledge graphs, what's a knowledge graph? It's basically a graph where you can describe objects of interest and connections. And we're interested mostly in organizing data as nodes and edges. And if you use any search engine like Microsoft, Bing, or Google, you're using a knowledge graph under the cover. So every time you issue a query, and there's an entity on the right that has the name of the person, the age, what they do, et cetera, that's kind of powered by either Satori, which is the Microsoft knowledge graph, or the Google knowledge graph if you happen to use Google. This notion of building knowledge graph is taking off in many other companies. A year ago, Amazon announced that they're building their Amazon product graph, and there's a big team in Seattle basically building a graph, as well as eBay doing the same. And at the same time, it's been a lot of work in the past, many decades under the umbrella of knowledge bases. So you may be familiar with Yago, which was done at Max Planck, other things like Freebase here in the Bay Area that then later was acquired by Google. The terms knowledge graph and knowledge bases are mostly used interchangeably. In this talk, I'm not going to describe what's the difference between them. I'm just going to say that the focus in this short talk is mostly on the construction or generation of the graphs, and not so much on the reasoning. The second part is we're interested basically in scalability and fast generation, which means can we scale the construction of all these graphs, and how fast can we do this? So the goal is to identify nodes and derive those edges, and how can we do this automatically? So far, most of the research on knowledge graph and knowledge bases, they usually use Wikipedia as a source. So this is very good because the benefits of Wikipedia, the content is easy to read, it's well structured, it's a wiki, it's easy to parse, there's Wikipedians who are going to edit and so forth. The drawbacks is obviously coverage. Not every topic is in Wikipedia, only the head topics or the sort of important topics are on Wikipedia. A lot of stuff is outdated, and if you get into real specific things like biases, there's a lot of bias in some of these Wikipedia articles. Now the problem is, what do we do when there's no Wikipedia? So what do we do if there's no Wikipedia, and there's plenty of examples in real life where you don't have Wikipedia? And if you don't have Wikipedia, how can you derive a graph? And that's this talk. The first one is SKG, the social knowledge graph. We have, if you're really interested in the topic, I have pointers to papers that we publish. So we have one in CIR and the other one on JCDL that kind of gets into the details of all of this. But high-level overview, observations on working with Twitter data. At Microsoft, we used to have access to Twitter data for about 10 years, 10 years. So we paid for the firehose, and we store all Twitter data, and we did a lot of stuff on top of that. So after working for nearly a decade on Twitter data, my observations are the following. So drinking from a firehose is very, very hard and very difficult. There's very low level, there's low value at the atomic level on a tweet, on a Facebook post, on a Foursquare check-in, et cetera. But at the same time, there's a huge potential to build new artifacts. And this applies to aggregations, going beyond recommending tags or friends or accounts or trending topics. And the idea was how to build, if it was possible, to automatically generate a knowledge graph out of Twitter data. And I firmly believe that all these ideas are applicable to other social networks like LinkedIn or Facebook. All right, so SKG, the input is very simple, the firehose, the Twitter firehose, and the output is a knowledge graph. Simple, right? So we're going to identify 4 components of our graph. So the nodes are going to be the links, the topics, the entities, in this case people, organizations, and places, and then over time. And I'm going to go back to this and tell you why time is super important in social networks. So we're going to look at the graph from those views. And we're going to focus on super high quality content, relevant content from trusted users and good topics, and I'll go through this as well. This is a core schema. Looks complicated, but I'm going to just highlight the main things. So we have users, posts, topics, and links. And imagine this is kind of an OLAP view, if you want to call it. Or if you're very familiar with Excel, imagine you just read the entire firehose in Excel, and then you play with pivot tables. Something like that. Right? So you have tables of users, everything that Twitter is going to give you, plus things that we automatically derive, like static rank, an authoritative score. Then we have the links, the same, what's the static rank of the link, the topics, and the post. This is important because we call them supporting evidence or provenance, as people would call it in databases, when you want to check a particular edge or node. Then we're going to build a lot of different subsets. One of them is the notion of verified users and trusted users. So if you're in Twitter, you have this check mark, that's you're verified, but it's just a manual process from Twitter. So what we did is we built an activation network that will just take the verified users and automatically scale the number of users that we call them trusted. So if Bill Gates, who is a verified user, adds me in Twitter and I add him back, then I'm a trusted user. So then if I add Sophia and Sophia adds me back, then she's a trusted user on ring number 2. So from Bill Gates on ring number 0, I myself on ring number 1, Sophia on ring number 2, etc. So in a few hours, we have a massive data set of trusted users. Then we look at links. So we have good links, and then we have viral links, and then we have trending links. And if we dive into topics, a topic should be a hashtag, could be an entity. An entity here means we use an NLP entity extractor to extract tags from a tweet. Cash tags, which is basically the $sign next to MSFT, will mean that you're talking about Microsoft in the context of financial information versus the pound MSFT, which is the topic Microsoft. And then other things like engrams, trending, and a bunch of annotations. All of this to say that we take a massive firehose, and then we shrink it into these kind of 4 nodes of user, post, topics, and links, and then we build a lot of different connections, which allows you to, given a user, we can see what are the links, what are the topics, examples of tweets. Given a link, who are the users who are sharing this link, posts that retweet this link, and so forth. All right, so far, so good. We had a graph. What do we do with it? So here's the application. Here's kind of the cool application. Once we have a graph, we want to basically build an application that will tell you the evolution of a story. So here's the pitch. There's a lot of social posts on something that they will make it into a few news articles, and some of them will have a single one Wikipedia page. All right? Those are thousands of posts that end up into a few hundred news articles into one Wikipedia page. That's the planet, a few editors, and maybe 1 or 2 Wikipedians. You can guess, obviously, the bias and coverage and all those things, but that's not the point. The point is, can we leverage this human scale, this kind of human sensing on the planet, and then combine it with Wiki, and can we automatically build you a Wikipedia page based on social data? That's the application. So we're going to use Twitter as a distributed human crawler. All of you guys are sharing links. So we're going to extract all the links from Twitter as part of a backbone of the story, and then we're going to put a Wikification algorithm on top of it. So once we have the graph, we run the Wikification algo on top of it, and then we'll build you this thing, which is kind of a database of stories. So it's a synthetic document. I'll give you another example later that gives you provenance, supporting evidence, evolution, and different pivots to play with different linkage. And you can archive, by the way, so you can kind of archive what was said. And the idea why we wanted to do this is because we wanted to get an idea of the evolution of the US election. So why Trump was elected as president, everybody's or happy or sad, but we wanted to see how we came out to elect Trump. So that was the evolution of the story. So here's the processing pipeline. We're going to harvest the data, we build our graph, and then we're going to build a couple of extensions to well-known information retrieval techniques. One is pseudo-relevance feedback, so we're going to expand that, also the query expansion. So we get the graph, then we have all the links, and then we expand all these things with extra metadata, and then we're going to build the story on top of it. For that, the idea of counting votes or likes or retweets is kind of shallow. It doesn't give you a lot of signal for all these things. So we build our kind of different voting data structure here, where if you just use basic counts, as I said before, it's very artificial, the popularity. So then we're going to count by different things. We're going to count the links, the co-occurrence of the links with the hashtag, the co-occurrence of the hashtag with the link with the person, and so forth. So we got all this combination of different ways of computing votes. And imagine like a record of different ways to count different votes. Once we have this, the second part of the puzzle is to build a hashtag index. So it's just an index of hashtags and an explanation for those hashtags. It'll be like this. So we have the hashtag index, and then if you're looking at hash recount 2016, if we're looking at December the 2nd, which is the first entry, it's mostly about some issues going in Wisconsin about the recount, and then hashtags audit the vote, Wisconsin recount, etc. If you go forward one day, the recount is to a different state, in this case, Michigan. So those are the timestamp, the entry, the contextual vector, which is kind of a signature of what people were talking about that hashtag, the signature, which is a similar idea, kind of a summary of what the link was shared. That's the URL, and then these related hashtags, which allows you to pivot. So if you're looking at recount 2016, you can say, oh, there was an issue with the Wisconsin recount or the Michigan recount, and you can go to that story. So you're kind of making those linkage automatically. Same way, we're going to use this to expand the notion of pseudo-relevance feedback and query expansion. I'm just going to give you this, but it works as is. For example, Super Bowl is a very popular hashtag, but its equivalent of SB50 was only on 2016, and SB51 was only valid on 2017. However, Super Bowl was valid for both years. So the lesson learned here is in social networks, time is crucial because context is only valid for certain amounts of time. So we're going to capture this. So we're going to capture all these things for the different expansions. We're going to use SimHash, which is a clustering technique for grouping similar hashtags. And then obviously we used to have access to the Bing search query log, so there's a lot of queries on the search engine that give us, trending things and so forth. Anyway, all this to say it's a big linear combination to give us a score and allows you to do things like this. If you're issuing the query Clinton in July 31st, one of the most popular hashtags was Hillary Clinton, and that's the vector, the definition for that day. But at the same time, on that day, she was mostly mentioned in context of Benghazi, and that's another definition for the hashtag Benghazi. On the 27th, then there's Clinton's email scandal, communist resignation, that's the relationship. If you go to Trump, by the way, I'm just using US election because if you're really into data mining and all this crazy stuff, please download the US election. There's plenty for pretty much for everything you want to do. US elections is always the data set to go. On August the 4th, Trump train related to Make America Great Again. Then on the 16th of September is Trump Nation, Trump Army. Political stuff, obviously. Bernie or bust, then millennials, should have been Bernie, and then still Sanders. All these things, you're kind of automatically discovering there's relationships because people are just kind of tweeting or linking things, and under the graph, we're discovering this linkage automatically. And then the final note, moving away from politics, on October 3rd, obviously Star Wars, that's Rogue One, but because Carrie Fisher passed away, then Rogue One was associated with Rest in Peace Princess. All those things are detected automatically. Why I'm pitching this to you guys, because all these things is very hard to put it in Wikipedia documents or have someone coming in your company to do all this linkage for you. So here, which is kind of piggybacking on top of the user base. Once we have this, the rest is building the story, and the story is traversing the hashtag index, looping through all these tables, re-ranking the links, and creating the story. And this is kind of the summary of the story. This is the story for the US elections. It looks like a Wikipedia page because it was derived using the same style as a Wikipedia page, but under the covers is all data coming from Twitter on top of the graph. So the table of content is heatless clustering, then the story evolution. Generation is what I just mentioned to you. Then we have the related stories because we're making these connections. This could be the hashtags related to other hashtags. The sources, because you're sharing a link, then we can detect the source, the domain of that link, and that will be the source of the reference in the page. So we're not making this up. This is the story told by the planet. So it's not Washington Post View or the New York Times or somebody else. The planet is giving you the story, which is good because it will have all these different perspectives, which is, I think, very useful. And because people were looking for this, the story already embeds the queries. So the queries already know how to fire and when to fire the story. This is a comparison of the Sonoma fires from our page to the official Wikipedia article, and we're as good as the Wikipedia article. And all this to say that a year ago, you can fire this on Bing, and what you see on the rundown was basically the story that was populated and powered by the graph. All right, that's graph number 1. Graph number 2, again, another publication. We're going to switch context and go from social media to e-commerce. So here is, we're going to look at brands, products, and categories. Scenarios are, you're issuing a query for the brand Microsoft, and you would like to see all the products, Office, Surface, Windows. Or maybe you're looking for a product, for example, jeans, and I want to get brands, Calvin Klein, Levi. Or I'm querying for the category, smartphones, and I want to return iPhone, Galaxy, or Pixel. This is interesting because a product can be an item or for sale or a service. It could be Adidas Samba, or it could be an insurance policy, or it could be the food delivery. If you do this, you can detect competitors. The fact that Nike and Adidas both sells running shoes, then I can derive that Adidas and Nike are competitors. And in an e-commerce scenario, like for example serving ads, this is very, very important. So then I can detect related products, related brands, product families, and so forth. Sounds simple and trivial, but there's a lot of different challenges here. The first one is this is a very dynamic domain. So you got different brands and products. They appear and disappear as we go. There's a lack of major sources with clean brand and product data. So Wikipedia will cover Nike and Adidas, but for the torso and tail of the distributions, there's basically nothing, absolutely nothing. It's very hard to define and detect products. And sometimes the distinction between a brand and a product is kind of blurred. It's very difficult to see. And retailers don't always going to provide clean data. So what's our approach is unsupervised. We're going to focus on data quality and simplicity. We're going to generate brands using data fusion and voting schemes. Then we're going to tag the brands with categories, and from that we derive the products. So in a nutshell, it works like this. We're using a voting mechanism, so given n number of different sources, each source will vote if they see this particular term or token. And if this goes above a specific threshold, we can derive with some confidence that Adidas is a brand or Nike is a brand. Once we do this, we go into the search query logs and try to extract the most frequent domain at position number 1. This is good because give us, for example, for a particular term, Apple, an alias, for example, Apple Inc., Apple Computer, they're all pointing to apple.com, which seems to be the dominant domain for this brand. And here a score of 1 means that all of the sources understand Apple. But if you go down the list, you'll see things that people are not very clear, particularly for small merchants, which will have a presence on the web, but they're not super popular. Once we have the brands and the domains, the second step is to derive a category. This is also very, very hard. So how we categorize Apple? Do you think Apple is smartphones, is electronics? It's also fashion. You know why? Because they sell watches, right? That's hard. So we start from a brand, then we extract all the URLs. We're going to search for queries that point to this URL. From those URLs, we're going to extract all the categories. We're going to do an aggregation on the categories. At the end, we're going to derive a list of categories that are associated for a brand. We're going to compute a lot of different probabilities, in particular the probability of a category given a brand, the probability of a query given a URL, and making, again, other use of formulae. We're going to get what's the list of different categories for a brand, and with this, we can also give you the popularity of a brand. Once we have the brands, the categories, and domains, the last piece of the cake is basically how to derive a product. So we derive products from 2 ways. One is from the retail catalog, so say Walmart.com kind of dumps data onto you, and then we have to basically identify which of these n-grams do actually match a particular brand, and then use other things, like for example, deep structure semantic modeling, which is a Microsoft thing, on top of the product ads to detect some of those names. Then we use scheming, clustering, with a bunch of heuristics because the clusters are very large. And then at the end, we generate a set of m different labels. This is just using the catalogs. There's another set of techniques for using bidded keywords, the keywords that an advertiser will use to bid on particular search query terms. That's another different techniques, engrams, language models based on KL, et cetera, et cetera. This also tell you that from nothing, from different vast sources, we can kind of one by one build all these little components, and at the end, we can give you a graph. In terms of the system design, because we're using a wide range of data sources, you can add new data sources as you go, and they're not going to affect the voting schemes and how we derive all these things. This is a very bottom-up approach with a focus on simplicity and data cleaning. So we have to have data cleaning as part of the data in the graph, so we're trying to kind of weed out everything that is not so clean. This same as the previous project with social data on Twitter. These are all implemented in Cosmos and Scope, which is the Microsoft equivalent to MapReduce in Google. They work very well at scale. All right, third graph. This will be knowledge graphs for healthcare. So I talk about social data, Twitter. You're all mostly folks here are familiar, as well as e-commerce, Amazon. But this is a different beast. Why? Because there's very strong scientific medical knowledge out there. There's a lot of existing taxonomies and data sources available for this. For example, you have SNOMED, which is the Systematized Nomenclature for Medicine. You can download. There's RxNorm, which is basically a taxonomy of all the available medications in the US. Then you have MESH, medical subjects headings, and a bunch of other different sources and taxonomies. Everything kind of looking at a particular view of healthcare. The challenges here are the following. One is this is extremely sensitive data. So it's not a tweet, okay? It's not a link. I don't care about hashtag MAGA. This is your medical records, right? So this is very, very sensitive. And if you have access to a hospital and you have medical records, it will be great and it will be fantastic to kind of derive kind of a knowledge from these things. The third item is the notion of relevance in healthcare, and we call this clinical relevance. So you know relevance in web, we know popularity, relevance in Instagram or Twitter, but what's relevance in a medical domain? So we go into the emergency room for something, the doctor will check you to give you context, what happened, check your records, situation, and then make a call on what things are relevant or not. Then there's a vocabulary mismatch problem. So the doctors, they're very precise on the terminology, but we as patients were completely imprecise. Hurt here, I don't feel well, etc. So you have a mismatch in terms of terminology. And then if you want to do machine learning on top of all these things, data labeling and curation in this particular domain is super hard. Not only because of the sensitivity of the data, because who is going to label these things? Are we going to hire more doctors? Who is going to label? So can we do active learning, label propagation? All those things are super handy in these domains. And what are we trying to build at Curai? I just started a couple of months ago, so I don't have a lot of beef to show you at the moment, although Sophia is going to give you a great presentation on humanity in the loop. But we're trying to build a comprehensive medical knowledge graph that will cover diagnosis, symptoms, descriptions, etc., as well as labs and medications. If we do this, and we're doing this, we can run question answering on top of it, and we can produce automatic diagnosis, which is what we want to do. Part of this scheme is to have a very rich human-in-the-loop data pipeline that will have the knowledge graph under the covers, a bunch of ML and AI algorithms, but also kind of a health coach or MD, medical doctor, in the loop to hopefully give you the best diagnosis possible. To conclude, and I really rushed this presentation, so happy to take questions or talk offline. This is a super active area in academia and industry. If you're subscribed to the CACM, there's a great article in August this year where they talk about the importance of knowledge graph, and the article is co-written by Microsoft, Google, Facebook, and eBay. Just to give you an idea how important this area is, there's a lot of many workshops on knowledge bases and knowledge graphs in top-tier conferences. And in the field, this requires a combination of many, many different techniques. So large-scale processing, information retrieval, machine learning, AI, NLP, labeling, etc. So you cannot do it by yourself. You have to work in a team who is very diverse. And at the same time, which is super important, you have to have domain expertise, because you're not going to build a KB or a knowledge graph off the shelf and then sell it. So you have to do it in the context of a domain. And sometimes either you are the expert on the domain or you were working with domain experts on this. And that's about it. Thank you so much for your attention. There's time? Yes, if not. Sure.
Any questions?
Thanks for the talk. I had a question about your knowledge graphs for generating for brand and product. Mm-hmm. You talked about generating representative labels for products, like kind of pruning down on a larger set of tags or words that you would consider to be a representative label. What were some of your concerns and trade-offs when you were choosing something that could be displayable or representative?
You're gonna have a lot of different labels, and sometimes some of these things are unclear. In particular, when you have models and versions. In case of apparel, for example, this T-shirt would be size M or L. So sometimes the jeans shirt is good as a product, but sometimes you get extra information that maybe is a bit redundant, or doesn't help you a lot, because you may detect many products that the variations are on these little things. Particular quantities or models or variations. On the other hand, sometimes you have super high labels, like shoes, and everything could be shoes. Can you get into more detail? So that's something that the team is still working on. But when we started working on this, that was one of the early things that we noticed. So if you do the top 5, for example, of the products for Microsoft, they were very good. But if you go down the list, some of the things are like dupes, near dupes, and a lot of different versioning or extra things that don't add a lot. Because a company won't sell like millions of products. Usually it's just kind of a small set compared to everything.
Just a pair of questions. The knowledge graph you're trying to build, it seems to be from like the medical textbooks and the EMR information would kind of give 2 distinct sets of information. Are you looking to try to merge them into one for like a kind of a holistic picture of kind of health or ways to help individuals or doctors?
That's the idea. So the idea that we're working on is to build kind of a unified knowledge graph of healthcare. Like I said, I just joined. I'm claiming that we have everything ready, but that's our direction. So there's a graph. There's medications and drugs that we're trying to ingest. Once we have these this graph of diagnosis and symptoms, and also questions, which I forgot to mention. There's many ways of asking if you're sick or not. There's many ways of or telling your doctor you're sick. Once we do that, imagine you have this graph, and obviously you can kind of ingest part of the graph into an EMR or make it an EMR, an application on top of the graph. So we have First Opinion, which is our application that it's available if you want to play with it. That basically uses the graph under the covers, and has we're launching a new version that will have some of these autocompletes that are like more fancy. But that's the plan of Curai. That's where we're trying to go. Happy to take questions offline. Thank you very much for your attention.
Great. Thanks, Omar.